So today I am going to start a new chapter, and that is ordinary differential equation. Okay, ordinary differential equation, and the importance of this chapter is one question directly asked from this ordinary differential equation, and one question of classical mechanics belongs to this category, and one question in general from some mechanics part has been asked, that also after writing the Newton's equation it becomes a ordinary differential equation that has to be solved. So that's why this chapter is very very important. In quantum mechanics also, you know when you will write Schrodinger equation, and that will become a second order differential equation that has to be solved using the boundary conditions. Okay, so because of all this chapter is very very important. Okay, so let me just give you the outline of the topic that we are going to study. First number is we will discuss equations of first order and first degree. Okay, we will discuss equations of first order and first degree, and in this we will discuss variable separable equations, then homogeneous equations, and reducible to homogeneous. Then C will be linear, and then we will have reducible to linear equations, and D will be exact differential equation and reducible to exact. Okay, so this is the first part that we will discuss, and the second part will be second order equations, second order differential equations. In this, first of all, we will discuss equation with constant coefficients, equation with constant coefficient, and then Euler's form, Euler's form, and uh, this will be homogeneous, and then C part will be uh, this will be homogeneous. C part will be non-homogeneous. Non-homogeneous. Okay. So this will be the complete syllabus of ordinary differential equation. आपको कैजुअल नहीं रहना है कि ये तो यार आता ही है, अगर आता भी है तो भी आपको साथ साथ जो है उसको अच्छे से पढ़ना है, so that I mean let us revise it. If you know everything, just sincerely you have to revise it. And you have seen the toughness is not about knowing the concept. The toughness is using it very very frequently, very very smartly. Okay, that is that is where the toughness lies. Okay, so like we started in previous chapter from the concept of poles, residues, those small concept we started, and then finally, in a single question you have to use each and every concept very very quickly. So that will happen in this case also. So we will start from the very basics, and then we have to use those concepts very very frequently. Okay, so let me start. Okay, so let us begin this. So, you know, every problem, every problem is formulated finally in the form of a differential equation. Each and every problem, whether it is a problem of engineering or it is a problem of physics or science, each and every problem is formulated in the form of a differential equation. So that's why, you see so many differential equations in physics. Like Schrodinger equation is a differential equation, like wave equation is a differential equation, like Newton's second law is written in the form of a differential equation. So you find so many differential equations in in physics, in engineering, etc., etc. Okay, so it comes because आपके पास एक quantity है, you have a quantity and that quantity is varying with respect to another quantity. Okay, there is a rate of change or there is a gradient. Rate we use when it is with respect to time and gradient we use when it is with respect to position. Okay, so there are variations. So to formulate those variations, what we do, we form a differential equation. Okay, so suppose you see a differential equation like this, dy by dx. The differential equation is like this. So this x is known as independent variable. This is known as independent variable, and this y, this is known as dependent variable. Dependent variable. So this is independent variable and this is dependent variable. Okay, so if you have only one independent variable, if you have only one independent variable, then the equation is known as ordinary differential equation. Okay, and if you have more than one independent variable, then it is called partial differential equation. Okay, so ordinary differential equation and partial differential equation. Okay, so this is another chapter which I will just follow after this ordinary differential equation. We will discuss partial differential equation. A partial आप तभी कर पाओगे when you are very very fast in ordinary differential equation. Okay, so uh, that's why ordinary हम लोग बहुत अच्छे से करने वाले हैं. Now suppose this is n, so this is called order. Okay, the highest this, suppose in a differential equation you have d2 also and dy by dx also, then you will see the highest n, that will be known as order of differential equation. And suppose this is some power, suppose m. Okay, so m should not be fractional. Suppose it is 3 by 2, so you will square the equation. Okay, so this is called degree. Okay, so this is order and this is degree of differential equation. ठीक है, so with this brief introduction, let me come to the topics. So let us come to the topic. uh, the first one is first order and first degree, this type of differential equation, first order and first degree differential equation. And I told you in this we will be discussing four different type of differential equations. Okay, and starting from variable separable, homogeneous, then reducible to homogeneous, and then linear, then reducible to linear, then exact, and then reducible to exact. So all these cases we have to discuss. Okay, so the first one is variable separable. The first equation is variable separable equation, and this is most fundamental because suppose you have two types of variables, one is dependent variable and one is independent variable. So if you can separate them about your equal to sign कि एक part पे you have only x और दूसरे part पे you have only y, then only you can integrate the equation. तो इसलिए ये सबसे ज्यादा फंडामेंटल है, बाकी जो चीजें हैं वो इसके साथ ही आती हैं, ठीक है. तो लेट मी फर्स्ट ऑफ ऑल क्विकली टेल यू ऑल द मेथड्स, देन वी विल डू क्वेश्चंस, ठीक है. So this is very simple. Suppose we have dy by dx is equal to, suppose we have y by x. Okay, suppose it is like this. Then you can integrate it if we have dy by y is equal to dx by x. Now this side only contains y and this side only contains x. So now we can integrate them like this. Okay, and since it is indefinite integration, you will get a constant also. Okay, so let me integrate this first. So I will get log of y is equal to log of x, and let me write it like log of c, the constant. Okay, so it will become log of y is equal to log of xc, and the solution will become y is equal to xc. This is the solution of the differential equation 1. Okay, this is the solution of differential equation 1. I mean, this is one solution of 1. Okay, and the solution may be written like this: y is equal to xc clearly, or sometimes you will not be able to write it in the form of y is equal to xc. So this is known as explicit and that is known as implicit. So like some equation is there, you got some complicated equation, but that is also a solution. So there are three kind of solutions and all three are accepted. One is like this, second one will be in the form of equation, and third one will be graphical. So graphical solutions are also accepted. Okay, graphical solutions are also, so all three type of solutions will be accepted. So this method is known as uh, variables separable method, and the order, one thing I want to tell you, the order of differential equation is equal to number of unknown constants in the solution. Number of unknown constants in the solution. The order of differential equation is equal to number of unknown constants in the solution. Okay, so let me quickly introduce the next one. Can I read from this book? Second one is homogeneous. Homogeneous. Okay, what is homogeneous? You have a differential equation like this: dy by dx is equal to some function of xy here phi, and suppose in denominator also you have some function, for example I write it like this, psi of xy. Okay, dy by dx is equal to phi of xy upon psi of xy, and both terms should have same degree. And you know what is the meaning of degree of algebraic equation? That should be same. So how to solve it? Yes, so there is a method. We put y is equal to v of x. This is the method to solve homogeneous equation. Then what will happen? Dy by dx will become x times dv by dx plus v. Okay, you replace this equation by this, and then it will become variable separable. Then it will become variable separable. Okay, it will become variable separable and you can solve it. So let me give you one example to understand this. suppose I take an example, y square minus xy and dx plus x square dy is equal to 0. Suppose this is the problem that we want to solve. Okay, so write this as dy by dx in this form. What will happen? Dy by dx will become xy minus y square over x square. Okay, so now this is in this form and all the terms have degree 2. That is the important thing, that degree should be same, otherwise you can't use the homogeneous method. Okay, so now let us substitute y is equal to v of x, then it will become x plus sorry, v plus x dv by dx is equal to, write this part, it will become y is equal to vx. क्या बन जाएगा? vx square minus v square x square over x square. So x square will be cancelled. So is this correct? So this will become 0. So what you will get? X times dv by dx will be equal to minus v. Okay, and dv over v is equal to minus dx over x. So it is v minus v square. V minus v square. So v will be cancelled only. Huh? So it will become dv over v square is equal to dx over x. Correct? And when you integrate it, minus 1 by v is equal to minus ln x plus ln c, and this will become minus 1 upon uh, v is equal to y by x, so it will become minus log of xc. Okay, so this will be cancelled and you will get y as x by ln of xc. Okay, this is your solution. Okay, so see the methods then. In first round just understand the methods, in second round we will solve many questions. In first round only just quickly understand the methods. Now next is reducible to homogeneous. Okay, the next method is reducible to homogeneous. That means suppose you have a equation like this, reducible to homogeneous, and the equation is like this, dy by dx is equal to some, suppose there are coefficients of x and y and we have to separate them. Okay, so you have suppose ax plus by plus c over some ax plus by plus c. Okay, like this. Suppose the equation is like this. So what is happening in this case is uh, here degree is 1, यहाँ पे degree 1 है, degree is 1 and here degree is 0. So it is not homogeneous. So first of all what we will have to do is we have to make it homogeneous and then we have to apply the method to solve homogeneous equations. Okay, that is the only way of doing this. So how we do this? We put a small x is equal to capital X plus h and a small y is equal to capital Y plus k. See this carefully, and then we will get d capital Y by d capital X, because d small y will be equal to d capital Y and d small x will be equal to d capital X, because these are constants. Okay, and they will become a times x plus h plus b times y plus k plus small c over a times x plus h plus b times y plus k and plus capital C. Okay, so that is equal to it will become ax plus by, ax plus by plus ah plus bk plus small c over what this will become, ax plus by plus ah plus bk plus capital C. It will take this form. And now you see, because h and k we have taken h and k, so what I can do is I can make the selection of h and k is in our hand. Okay, so I can take the values of h and k such that ah plus bk plus c and ah plus bk and c, they simultaneously become 0. Okay, and there is a condition that this should be solved, because you know in some cases this cannot be solved. In those cases we can't apply this method. Okay, so if these two simultaneously become 0, if these two simultaneously become 0, then what will happen? Our equation will reduce to d capital Y by d capital X is equal to ax plus by over ax plus by. Okay, it will reduce to this, which is actually homogeneous. You can solve this by putting y is equal to v capital X and making it variable separable. You can solve it, and finally your solution will come as y is equal to some function of x. It will come like this, but we don't know solution, we don't need solution in capital Y and capital X. We need solution in small y and small x. So what you will get, you will calculate the value of h and k from these two equations. Okay, and you will put here, you will get the values of capital X and capital Y and again substitute it here to get the final solution in the form of y is equal to some fx. Otherwise ऐसे कई बार clarity नहीं आती है. So let me give you an example. So that is dy by dx is equal to dy by dx is equal to x minus y minus 2 upon x plus y plus 6. Suppose this is the equation. You can clearly see this is not a homogeneous equation. Yes, this is, but this can be reduced to homogeneous. Okay? So how to do this? So please learn the methods. What to do? I will substitute x is equal to capital X plus h and y is equal to capital Y plus k into this equation, and tell me what it will become. It will become d capital Y over d capital X is equal to this side capital X. So here you will put capital X plus h, na? So minus capital Y and plus
minus k.
H minus k minus 2.
minus 2 upon here capital X
X plus
plus
y
capital Y plus
plus h plus
h plus k plus 6. Now you have to make these two equations simultaneously 0. If these two are simultaneously 0, because h and k are arbitrary, I mean we can not arbitrary, we can choose them. So we will choose so that these two equations become 0. So this will become h minus k minus 2 is equal to 0 and h plus k plus 6 is equal to 0. So if you add them, it will become 2h plus 4 is equal to 0. So h is equal to minus 2. देखो जरा, is that okay? The value of k, if h is minus 2, it will become minus 4. So this is gone now. So let me erase this. This is now gone. These two equations simultaneously became 0. Now we have to solve this equation by putting capital Y is equal to V capital X. So what this will become? It will become V plus capital X dV by dx. यही तो था Vx. So it will become 1 minus V. You will put Vx here. So xx will be cancelled
1 plus V, sir.
over 1 plus V. Okay. Now remove this from here. Put it here. It will become 1 minus V. And what about this? Minus V minus V square over 1 plus V. Okay. So what will be the variable separable that we are going to get? So ये याद रख लेना h और k की value. Let us write somewhere. H was minus 2 and k was minus 4. And what about this equation? So this is in the form of 1 plus V and dV by 1 minus 2V plus V square and is equal to dx over x. Sorry, minus V square. Minus V square is equal to dx over x. Clear? Now you have to integrate it. So you can put the value of this as a derivative of this. याद है ये वाला method? 1 plus V will be equal to, so 1 plus V is equal to, what you will write? This you will write as some A times d by dv of 1 minus 2V minus V square plus B. Write it in this form. ये क्यों लिख रहा हूं पता है ना, ताकि इसका डेरिवेटिव ऊपर आ जाएगा तो इसको t मानोगे तो वो dt बन जाएगा अपने आप. ओके. So what this will become, 1 plus V is equal to A times, इसको लिखना है जरा, 0 minus 2 minus 2V, okay, and plus B. So it will become minus 2V into A minus 2A plus B. Now compare the coefficients. So minus 2A plus B is equal to 1. Okay. And what about this? This value? Minus 2A is equal to 1. So what is value of A? Minus 1 by 2. And what is value of B? B की कितनी आएगी value? So B is equal to 0. So we can write this as 1 plus V की जगह क्या लिख सकते हैं? Minus half minus 2V plus 0 and dV upon 1 minus 2V minus V square is equal to dx by x. Now write this as t. This as t. So its derivative is in the denominator. Clear? So now you can do it quickly. So this part is what? If I put this as t, what I will get? Minus half. What is its derivative? This times this, na? Yes? Dt is equal to dx by x. I have substituted 1 minus 2V minus V square is equal to t. So minus sorry, minus 2 minus 2V dV is equal to dt. Okay. So this became dt and now you can simply integrate it. Minus half log of t is equal to log of xc. Okay, अब reverse process में जाओ, so you will write minus half log of t is 1 minus 2v minus v square and is equal to log of xc. Now v is y by x, so take the reverse process. 1 minus 2 y by x minus y square by x square is equal to log of xc, and take half here minus half here, so it will become 1 minus 2 y by x minus y square by x square is equal to xc. And what is the values of this? So small x was capital X plus h, small y was capital Y plus k. So capital X is x minus h, which is x plus 2. Capital Y is small y plus 4. Power is there, power can nahi ja rahi. So just substitute these values here and that is the answer. Because you want answer in terms of small x and small y, so just substitute these values into this. Okay, procedure is clear. Let me come to now the next one, and which is linear. You will see previous year questions, many times questions on this linear differential equations has been asked many times. Okay, so this is very, very important. Even the homogeneous, which I taught, a question was asked in jest on that homogeneous. So question is very simple, but if you don't know uh, the method, then you can't solve. And please understand, they avoid giving you a questions in which some very long method, or because they also understand that you have to finish that in 3 or 4 minutes. Okay, not more than 3 minutes. So that question can be done quickly, but just you have to know the method. Okay, so linear differential equation, first order, first degree we are doing. What type of equation is this? It is like this: dy by dx plus py is equal to q. It is in this form, and where p and q are functions of x only. If they becomes functions of y, the equation will become non-linear differential equation. Okay, so I have written here linear differential equation. So p and q has to be only function of x. So what is the method to solve such equations? The method is we get an integrating factor, which is e to the power integral p dx. This is the integrating factor which we calculate, and then the solution is given by, the solution of the equation is given by y into integrating factor that you have calculated is equal to integral q into integrating factor into dx plus c. This is the solution of linear differential equation. Okay, and please remember, here no constant will be there. Although this equation, this is uh, indefinite integration, but no constant will be written here. Okay, so this is the solution of the differential equation. Is that clear? So let me take a differential equation and try to solve it. The differential equation is given by, let me take one, dy by dx uh, plus 2 by x y is equal to cos of pi x over x square. It is given that y1 is 1 and they are asking y2 is equal to. So in during the solution of a differential equation, they may ask you the direct solution, they may ask you the value of the dependent variable at certain point like this, they may ask you the graph. So in many ways the question, many times you see previous year questions, so in differential equation they have asked that which one of the following is solution. So they have not given the solution in the form of a equation, but they have asked the solution in the form of the graph. So that is known as graphical solution. Okay, let us solve this. So पहले तो identify करो कि ये linear है. Identify it. dy by dx plus py is equal to q, and you can see that the value of p is 2 by x and the value of q is cos of pi x by x square. Both are only functions of x. So it is a linear differential equation. Quickly calculate integrating factor, which is given by e to the power 2 by x dx, which is equal to e to the power 2 ln x, which is e to the power ln x square, which is x square. Is that okay? Now what is the solution? Y into integrating factor is equal to integral q into integrating factor dx plus c. This will be cancelled. So y into x square will become, what is the integral of cos? 1 by pi
Mm.
sine of pi x plus c. Now apply this. This is known as boundary condition. If it is in time, it is known as initial condition. If it is in position, it is known as boundary condition. So apply that. जब x की वैल्यू 1 है, y की वैल्यू 1 है, so 1 1 1 by pi into 1 plus c, so this becomes 0. C is equal to 1, so c is equal to 1. So the solution is y into x square is equal to 1 upon pi sine of pi x plus 1. This is the solution, and they have asked the value at y is equal to 2, so y will become 2, this is 4, so sine of pi x over 4 pi plus 1 by 4. Sorry, the value of x is 2 na, so it is 2 pi, so this will be 0, so y की value, y2 की value आ जाएगी 1 by 4. Check this.